Hello friends, in this video we learn Cauchy's mean value theorem. Dear friends, if you are new to this channel, please subscribe the channel and press bell icon so that you can get updates of this channel. What is the Cauchy's mean value theorem? The statement of Cauchy's mean value theorem is like this. Let fx and gx be two functions which are both derivable in closed interval ab and g dash x not equal to 0 for any value of x in closed interval ab. Then there exists at least one point C in between a and b such that f of b minus f of a divided by g of b minus g of a equal to f dash c divided by g dash c. This is the statement. In the statement, there are two functions fx and gx. Both functions are derivable in closed interval ab such that g dash x is non-zero number. Then there exists at least one point C in between a and b satisfying the formula fb minus fa divided by g of b minus g of a equal to f dash c divided by g dash c. We shall prove this theorem. For proof, we define a function phi x, combination of fx and gx, like phi of x equal to f of x plus a into g of x, where a is an unknown constant. Phi x is defined as f of x plus g of x into a, where a is unknown constant. Then clearly, as fx is a derivable, gx is a derivable, then phi x is also derivable. Phi x is a derivable in closed interval ab, as f and g both are derivable in closed interval ab. Choose constant a such that phi of b equal to phi of a, that is f of b plus a into g of b. This is the value of phi of b, which is equal to f of a plus a into g of a. This is the value of phi of a. We choose a constant a such that phi of b equal to phi of a, and this gives us a equal to f of b minus f of a divided by g of a minus g of b. A equal to f of b minus f of a divided by g of a minus g of b, with ga minus g of b is non-zero. What happens if g of a and g of b equal to 0? Then g of a is equal to g of b and g dash c equal to 0 for some constant c. This contradiction to the hypothesis that g dash x is non-equal to 0 for any x. Thus, g of a minus g of b non-zero. Now, the new function phi satisfies the conditions of Rolle's theorem. Therefore, there exists at least one point C in AB such that phi dash c equal to 0. Phi dash c equal to 0, this implies that f dash c plus a into g dash c is also 0. Therefore, a equal to minus f dash c by g dash c. This we get. A equal to minus f dash c by g dash c. From this we can write that f dash c by g dash c equal to minus a. Minus a equal to minus times f of b minus f of a divided by minus a equal to minus times f of b minus f of a divided by g of a minus g of b, which is equal to f of b minus f of a divided by g of b minus g of a. Therefore, f dash c by g dash c equal to f of b minus f of a divided by g of b minus g of a, with g of b minus g of a non-equal to 0, as g dash c is non-zero for any c. This proves the Cauchy's mean value theorem. Cauchy's mean value theorem. In Cauchy's mean value theorem, we have a point C in AB such that f of b minus f of a divided by g of b minus g of a equal to f dash c divided by g dash c. Alternate form of Cauchy's mean value theorem. For getting alternate form, we replace b by a plus h. In Cauchy's theorem, we shall put b as a plus h. Therefore, the formula becomes f dash a plus theta h, g dash a plus theta h equal to f of a plus h minus f of a divided by g of a plus h minus g of a, where theta lies between 0 to 1. We note Cauchy's mean value theorem is a generalization of Lagrange's mean value theorem. When g of x equal to x, Cauchy's mean value theorem reduces to Lagrange's mean value theorem. We shall try to solve some example. Verify Cauchy's mean value theorem for the function f of x equal to x raised to 4, g of x equal to x square in the interval ab. According to the statement of Cauchy's mean value theorem, we have f of b minus f of a divided by g of b minus g of a equal to f dash c divided by g dash c. Here, f of x equal to x raised to 4 is given. Therefore, derivative of fx, that is f dash x, becomes 4x cube. And g of x equal to x square. This implies that g dash x is 2x. Fx equal to x raised to 4, f dash x is equal to 4x cube, g of x equal to x square, g dash x equal to 2x. By Cauchy's mean value theorem, if we substitute these values in this formula, we get b raised to 4 minus a raised to 4 divided by b square minus a square equal to 4c cube divided by 2c. b raised to 4 minus a raised to 4 divided by b square minus a square equal to 4c cube divided by 2c. From this, if we simplify this, b raised to 4 minus a raised to 4 can be written as b square minus a square multiplied by b square plus a square. And then b square minus a square get cancelled and we will get a square plus b square to the left hand side. From 4c cube, if we cancel 2c, we will get 2c square. Therefore, we will get a square plus b square equal to 2c square. And from this, c equal to square root of a square plus b square divided by root 2. This value belongs to open interval AB. Thus, Cauchy's mean value theorem is verified. We get that there exists a one point C in AB which satisfies this condition f of b minus f of a divided by g of b minus g of a equal to f dash c divided by g dash c. And hence Cauchy's mean value theorem is verified. Second example, verify Cauchy's mean value theorem for pair of functions sin x, cos x in the indicated interval AB. Here we shall assume that fx equal to sin x, gx equal to cos x. And according to Cauchy's mean value theorem, we get at least one point C in AB such that f of b minus f of a divided by g of b minus g of a equal to f dash c divided by g dash c. And from this we get sin b minus sin a divided by cos b minus cos a equal to f dash c is a cos c and g dash c is a minus sin c, which becomes minus cot c. But minus cot c can be written as sin of b minus sin of a divided by cos of b minus cos of a. Sin of b minus sin of a can be written as 2 times sin of b minus a by 2 into cos of b plus a by 2. And cos b minus cos a can be written as minus 2 times sin of b minus a by 2 into sin of b plus a by 2. And which is nothing but sin b minus a by 2 get cancelled, 2 get cancelled, which becomes cos of b plus a by 2 divided by sin of b plus a by 2 with minus sign. And that becomes minus cot of b plus a by 2. Thus, minus cot c equal to minus cot of b plus a by 2. This indicates that c equal to b plus a by 2. We know that b plus a by 2, this value belongs to open interval AB. And that's why C belongs to open interval AB. And hence, Cauchy's mean value theorem is verified. Next example, third example, show that there exists a number C in AB such that 2c into f of a minus f of b equal to f dash c into a square minus b square. When f is a continuous function in closed interval ab and derivable function in open interval ab. We shall apply here Cauchy's mean value theorem. For that we need two functions fx and gx. The fx is a continuous and derivable function is given in the problem, and we shall take that gx equal to x square, because here a square and b square, these terms are given. That's why we shall assume that gx equal to x square in closed interval ab. Clearly gx is also derivable function, and hence by Cauchy's mean value theorem we have f of b minus f of a divided by b square minus a square g of b minus g of a equal to f dash c divided by 2c. G dash c is a 2c, and hence for some c in AB we get the required result 2c into f of a minus f of b equal to f dash c into a square minus b square. Fourth example, if 0 is less than equal to a, is less than b, is less than pi by 2, then show that 0 is less than cos of a minus cos of b is less than b minus a. For this, we apply Cauchy's mean value theorem to the function fx equal to cos x and gx equal to x in closed interval ab. Why we are assumed gx equal to x? Because here b and a, these terms are given. If you take gx equal to x, then g of b equal to b and g of a equal to a. That's why we assume that gx equal to x. Then by Cauchy's mean value theorem, we have cos of b minus cos of a divided by b minus a equal to derivative of cos x is minus sin x, therefore minus sin c divided by derivative of gx equal to x is 1. Therefore we get cos b minus cos a divided by b minus a equal to minus sin c by 1. And here we get cos b minus cos a equal to sin c into a minus b. Since cos is decreasing in 0 to pi by 2, cos a is greater than cos b for a less than b. Therefore, cos of a minus cos of b is greater than 0. Also in 0 to pi by 2, maximum value of sin x is plus 1. So, since c belongs to ab and sin c is less than 1, we have b minus a into sin c is less than b minus a. Thus, 0 is less than cos a minus cos b is less than b minus a, which is required result. Fifth example, verify Cauchy's mean value theorem for the pair of functions 1 by x square and 1 by x in AB. Solution. According to the statement of Cauchy's mean value theorem, there exists a point C in AB such that f of b minus f of a divided by g of b minus g of a equal to f dash c divided by g dash c. Clearly, both the functions here 1 by x square and 1 by x both are derivable functions. Fx equal to 1 by x square, this implies that its derivative f dash x is equal to minus 2 by x cube. And gx equal to 1 by x, this implies that g dash x equal to minus 1 by x square. By Cauchy's mean value theorem, we shall substitute these values in this formula fb minus fa divided by gb minus ga equal to f dash c divided by g dash c. We get 1 upon b square minus 1 upon a square divided by 1 upon b minus 1 upon a equal to minus 2 by c cube divided by minus 1 by c square. And if we calculate this, we will get c equal to 2ab divided by a plus b. This a square minus b square divided by a square b square divided by a minus b divided by a b. 1ab get cancelled and a minus b, a plus b divided by a minus b A minus b get cancelled and there remains a plus b in denominator. And hence we get c equal to 2ab divided by a plus b. Clearly, this value belongs to open interval AB. Therefore, there exists a point C in AB satisfying this condition FB minus FA divided by GB minus GA equal to F dash C by G dash C. Thus, Cauchy's mean value theorem is verified. Example 5th. Verify Cauchy's mean value theorem for the pair of function 2x plus 1, 3x minus 4 in interval 1, 3. According to the statement of Cauchy's mean value theorem, we have a point C in AB such that FB minus FA divided by GB minus GA equal to F dash C by G dash C. Here we consider that Fx equal to 2x plus 1, Gx equal to 3x plus 4. Therefore, F dash x equal to 2 and G dash x equal to 3. Substituting these values in Cauchy's mean value theorem, we get 7 minus 3 divided by 5 minus 1 equal to 2 by 3. That is 4 by 6 equal to 2 by 3. This condition is satisfied for all the points in the interval AB. Therefore, Cauchy's mean value theorem is satisfied for every point in the interval 1, 3. Example 6. Verify Cauchy's mean value theorem for the pair of functions x cube minus 3x square plus 2x and x cube minus 5x square plus 6x in interval 0, 1 by 2. Solution. According to Cauchy's mean value theorem, FB minus FA divided by GB minus GA equal to F dash C by G dash C. Here we shall take Fx equal to x cube minus 3x square plus 2x. If we differentiate this, we get F dash x equal to 3x square minus 6x plus 2. Fx equal to x cube minus 3x square plus 2x. This implies that F dash x equal to 3x square minus 6x plus 2. Gx equal to x cube minus 5x square plus 6x. Gx equal to x cube minus 5x square plus 6x. Differentiating this, g dash x equal to 3x square minus 10x plus 6. By Cauchy's mean value theorem, we get FB minus F of A. That means F of 1 by 2 minus F of 0 divided by G of 1 by 2 minus G of 0. And if we substitute these values, we will get 1 by 8 minus 3 into 1 by 4 plus 2 into 1 by 2 minus 0 divided by 1 by 8 minus 5 into 1 by 4 plus 6 into 1 by 2 minus 0 equal to 3c square minus 6c plus 2 F dash C divided by 3c square minus 10c plus c 6 G dash C. From this we will get 1 by 5 equal to 3c square minus 6c plus 2 divided by 3c square minus 10c plus 6. If you transfer this term to the left hand side and 5 to the right hand side, we will get 3c square minus 10c plus 6 equal to 5 into 3c square minus 6c plus 2. And if we simplify this, we will get a quadratic equation and values of that are c equal to 5 minus root 13 by 6. 5 minus root 13 by 6. This value belongs to the interval 0, 1 by 2. Example 7. Verify Cauchy's mean value theorem for the functions fx equal to log of x, gx equal to 1 by x in the interval 1e. According to the statement of Cauchy's mean value theorem, we have fb minus f of a divided by gb minus g of a equal to f dash of c divided by g dash c. Here fx equal to log of x. This implies that f dash x equal to 1 by x. Gx equal to 1 by x. This implies that g dash x equal to minus 1 by x square. And if we substitute these values in CMV, we get log of e minus log of 1 divided by 1 by e minus 1 equal to 1 by c divided by minus 1 by c square. And simplifying this, we will get c equal to e divided by e minus 1. which belongs to the interval 1e. Thus, Cauchy's mean value theorem is verified. Dear friend, please subscribe the channel and don't forget to press bell icon so that you can get the updates of the channel. Thank you. See you in next video.